Although I'm gonna deviate a little bit, I'm gonna answer the learning objectives, for chapter 1, right? It's on the first page. You got 13 learning objectives there, okay? And as you're gonna see when I go through today's lecture, other than throwing in some of my own experiences to try to make it a little less boring and things, okay? I'm gonna go through these learning objectives. I have it marked that way when I'm looking at my book, okay?
Yes, sir.
All right, page 4. You guys are probably getting tired of hearing about safety, but the first chapter is over safety and quality control and quality assessment. When we get into the quality control and quality assessment, it's going to be probably a little bit of new material. You need to really pay attention to that. Some of this stuff, I'm fixing to replicate exactly what I told you in chemistry on the first lecture, okay? But I've looked at the test before I came to class this morning. Listen to what I'm telling you about the safety issues, okay? Because there are about, I think, 8 or 9 questions on the first test dealing with safety and quality assessment. Okay, the first thing on page 4 of your textbook in the left-hand column, you got something there, it's in bolded print, says the Occupational Safety and Health Administration, OSHA. What did I tell you guys that I wanted you to know about OSHA? Chemistry. You guys remember one thing, one word, starts with an S, safety. OSHA is responsible for safety, all right? Where they'll try to fool you at on a registry question is they'll put that in a multiple choice, and then they'll say like safety, quality assessment, and they'll also say standardization. But that is often a throw-off answer for what OSHA is responsible for. Just remember, OSHA is not just over laboratories, it's over anything in the workplace environment, construction sites, anything you can think of. It can be at a hair salon. They do something where somebody gets hurt in that hair salon, you're dealing with a safety issue, okay? So OSHA has to do with safety. Biological hazards. Says the healthcare setting provides abundant sources of potentially harmful microorganisms. These organisms are frequently present in the specimens received in the clinical lab. Understanding how organisms are transmitted, this is called the chain of infection. This is going to be one of your first objectives, is you have to know about the chain of infections. This is essential to preventing infections. Okay? Have you guys heard of the chain of infection before? How diseases spread. You got a big diagram on page 5, and I'm fixing to simplify it. For my class, okay, for what I think you need to know about this diagram, we're going to talk about it, but I have 3 things that I want you to know about the chain of infection. Your first objective says you need to list 6 things. I'm whittling that down to 3, all right? The first thing you need to know is a source. The second thing is the transmission. And then the third thing is a susceptibility host. That's the 3 things I want you to know: the source, the mode of transmission, and the host. Now, here's where I'm going to simplify it also. I'm talking about in the laboratory, all right? We're going to discuss something here in just a little bit called standard precautions. If any of you have ever been a nurse or in the nursing department in any way, PCP, CNA, anything, LPN, standard precautions is generally looked at applying to patients. In other words, what do you need to know about that patient so you don't get sick from the patient? How we interpret the chain of infection in the laboratory is we're dealing with patient specimens, okay? Just kind of pretend we don't deal with patients, we deal with their specimens. And those specimens can make you sick, all right? So that's what I mean when I say the source. I'm talking about for this class, that would be a urinalysis specimen, all right? Again, we're talking about the chain of infection and the precautions you have to take to protect yourself from that specimen. What do you think if you're working in the urinalysis laboratory? Again, I want you to think of this as common sense. If the specimen is the source, all right, we're not probably going to have mosquitoes landing in the urine specimens and flying from the urine specimen and landing on us as organs, right? Even though a mosquito can be a vector for a lot of diseases. When I'm talking about the urinalysis laboratory, what do you think is the #1 reason you can get sick from a urine specimen just sitting on a counter? What?
Accident.
Say that?
An accident.
Okay, what would be an accident?
You spill the urine.
Okay, all right. But if you spill it, what have you got on your body to hopefully protect you from that?
PPE.
Yeah, you're wearing gloves, you got a lab coat on, right? So you're already getting ahead of the game. Let's go back to the specimen, okay? Touching. That's what I want you to know about transmission in the lab. It has to do with you touching the specimen and you're not wearing gloves. Okay? So touching a specimen is the main mode of transmission. Now, what do you think the susceptible host is in a laboratory? Like, who are we worried about touching that specimen? The MLTs. Not only the MLTs, the phlebotomists, the lab assistants, the pathologists, whoever works in that lab that's around those specimens. Now, one thing that I want you to actually look at this picture on, I've simplified it where I'm telling you on the test it's going to be 3 things that are involved in the chain of infection, not 6. But when you do look at these, at the chain on page 5, if you'll look under a lot of those topics, a lot of them say breaks in the link. How do you break a link in the chain of infection? Okay, and if you'll notice in just about, these are the blue boxes, okay, on page 5. One of the things that just about all of those boxes, except for one, I think, that have in common is hand hygiene. All right? Hand hygiene is in every one of them. So what I want you to remember is the number one way that you can break the link of the chain of infection is washing your hands. That's the number one way you can prevent the spread of infection is to wash your hands. And you should already have gloves on, so really, if you think about it, as long as you're wearing gloves and you dispose of the gloves properly and everything, you're still required to wash your hands after you take them off, or you're supposed to. But wearing gloves is a big deal, but if you ever see a test question that says, what's the number one way to prevent the spread of infection? It's not wearing gloves, okay? And you'll see that as one of the answers. That's the throw-off answer that they're trying to get you on. It's washing your hands. Okay, on page 5, there's a couple bolded words there. One's called universal precautions, the other's called body substance isolation. They combined those 2 standards to make something called standard precautions that is on the top of page 6. On page 6, the very first paragraph on that page, you've got something there called standard precautions. But I do want to tell you, standard precautions is directed at how we protect ourselves from patients. But I want you, every time you see patients, I want you to think of a urine specimen or a blood specimen. Replace it with a specimen. I'm not going to read over all of these, but I just want to tell you things that fall under standard precautions that you need to be aware of is hand hygiene. That's the number one thing. Okay? Wash your hands, wear gloves. Number 3, mouth, nose, and eye protection. Number 4, wear a gown. In your situation, that's going to be a lab coat. Environmental controls are used. Linens, you're probably not going to be worried about that, but do remember that you may be called on to go to patients' floors and draw blood, right? If you're ever called upon to do that, okay, now you've got to be just as cautious as the nurses on that floor about using standard precautions. And I do want you to pay particular attention to number 8, occupational health and bloodborne pathogens. This is having to, what all of this is dealing with. You've heard this before, but in the laboratory, we are constantly,
I was just wondering, you said universal precautions plus body substance isolation make up what?
standard precautions. Those were the old standards, and they had discrepancies in them, like some of those standards, if you read it, which I'm sure you will, but if you read it, you're going to see some of the old standards, they didn't require that you take cautions unless you saw visible blood, okay? There were things wrong with those 2 other standards, so they modified them and made standard precautions because they found problems in universal precautions and body substance precautions. Okay, on number 8, I'm not going to read it, but I want you guys to think about something. we use syringes and needles in the lab a lot, especially if we're drawing blood. If you're working in an outpatient setting or in a clinic, whenever you have syringes, there's things you need to watch out for. First of all, syringes are always gonna be disposed of in what? Sharps container, okay? A lot of times, we take a cap off of a syringe. You are not, if you ever see a question about recapping a needle, you are not supposed to do it. Even though I've told you guys about the one-handed technique and all that type of stuff, you're not supposed to do it. The reason that I teach you guys about the one-handed technique is we train a lot on the dummy arms, okay? And I consider it to be okay if I know that you're not gonna stick yourself with a contaminated needle. Unless we wanna spend a lot of money, we can't go through a brand new needle every single time we're training on the dummy arms. And that's the only reason I've told you guys about the one-handed technique, okay? And I would never tell you to recap a needle or anything like that if you have actual real blood from a patient in that syringe, okay? So everything we have in the lab, just remember, you will never get in hot water about anything if you waste a needle in there or you're not sure. For example, Darren went in there and he was fixing to practice drawing blood. Let's say he went in there and it was a brand new syringe with a brand new needle on it, and it was still even in the paper, but maybe somebody had opened one end of it. Did you use that? Not, okay? Even though 99.9% chance somebody backed out. That's why it's there. That's why it's open. Somebody said, "Oh, I'm not going to do it," and they left it there. Okay. You still don't use it, throw it away, get rid of it. You do not use anything that you do not open brand new if you're fixing to stick a needle in somebody's arm. But be very careful once you get the blood in the syringe, because now you really gotta be cautious, because now you cannot stick yourself. And that's how come you guys get tired of me saying, like, don't pick the tube up and go to the needle. You just go to the tubes down there where there's no way if you miss that tube, a problem will occur. Now they do have devices if you have to go up on the floor now to where, when you may even be able to fill them in on this, where you actually hold like a glass plate that the tubes fit down. Is that correct, Wendy?
I'm not gonna just, my boy.
No, I know.
Okay.
I was talking about, did you draw blood all the time?
Yeah.
Okay, another objective, the very last paragraph on page 6 talks about the occupational exposure to bloodborne pathogen standards. This is monitored by OSHA. Controls are required by OSHA to provide, mandated by the employer for all employees. Specific requirements of OSHA standard include the following. You have to have engineering controls in place. That's going to deal with sharps containers, devices on needles for safety precautions, work practice controls coming into page 7, personal protective equipment, all of you know about that. Under medical, that's just stating that if you work at a healthcare facility, they are supposed to provide you with things like the hepatitis B vaccination. Now, you guys are going to be cutting them a break because you will have already had the hepatitis B vaccination, but if you didn't have that, they would be required to offer you that free of charge. Documentation, that has to do with everything. Number 10 there says documenting annual training of employees and safety standards. Everything, as you're going to see after we get through this lecture today, you have to have documentation about everything. Okay, this will answer one of your questions in the back of the book. Under number 13, that paragraph says, any accidental exposure to a possible bloodborne pathogen must be immediately reported to a supervisor. So, you stick yourself with a needle for whatever reason. Hey, it happens. People stick themselves with a needle. I mean, it happens more than you think. As far as a registry question, the first thing you're supposed to do is report that to a supervisor. I'm not saying I agree with this, but it even says you're supposed to do that before you flush the area with water. Okay? I've seen pathologists, I've seen them cut themselves with a scalpel when they're like looking at a colon or something in histology, and I'm just telling you, the first thing that I see him or her do, if they ever prick themselves or cut themselves with a lancet, is they automatically go over to a faucet and they squeeze their finger and run water. They don't go notify somebody, okay? But I'm not trying to deviate from the book. But if it was to happen to you, you need to report it to a supervisor, but let's just go with at the same time, be running your finger underwater and squeezing it, okay? If you ever cut yourself or nick yourself with a needle. You understand why you're doing that, right? I mean, you're trying to get any of that fluid that possibly could have went in from that needle. You want to try to get it out. Don't worry about milking it or squeezing it. Squeeze the heck out of it, okay? But run your finger underwater. I've never stuck myself, I'm just lucky because I know a lot of techs that have. I've never stuck myself with a needle, working in the laboratory, but it does not mean that you won't do it on your very first day of work. Okay, it doesn't mean you're a bad tech if you screw up one time and it happens. It's going to happen. But try to do everything you can to lessen the odds of it happening.
You're supposed to report it even if it's not a contaminated needle.
Yes.
What's that?
You're still supposed to report it even if it's not contaminated. Like if you open it up and accidentally stick yourself before you do anything else.
Use your best judgment on
You're
that.
supposed to, but
That's what I figured that you're supposed to, but it's more like,
I mean,
I just
plain
put
needle.
myself on the table, I'm not gonna go report an accident.
If you open it up out of a brand new bag, you poke yourself, I'm gonna let you use your best judgment on that. But I will tell you, if you make a report of a needle stick, there's a lot of stuff that's fixing to happen. You're gonna have to go to, you're gonna have to go get your blood drawn, they're gonna test you for HIV, hepatitis. Now, if there was blood in that, they're gonna find out what patient that blood was from, and then that patient's also gonna be tested for those things.
and they do drug screening.
If they're gonna do drug screen on you, make sure that you were, not, under the influence of anything while that
I got
happened.
a needle stick at National Park doing phlebotomy. I was taking the needle out, and he started talking to me when I was taking the needle out. He moved his arm and stuck me.
Did you report it?
Yeah.
Okay, and so fill us in on what happened, 'cause this is
Oh.
a good learning
I
experience.
had to flush my finger, and then I had to go tell Tammy, and then I had to get my blood drawn. They did a rapid hepatitis and HIV on him, and tested me, and a whole bunch of paperwork.
Did you even realize it when I
No.
imagine you were like,
No, 'cause it was a butterfly. He didn't even notice, and he's like, "Oh, I'm sorry, I didn't mean to move," but I was like, "Oh, it's fine." As I'm silently freaking out.
Every hospital has what they call like an infection control officer, and they are gonna oversee the entire process. Believe it or not, they used to, infection control officers in the hospital, they used to hire med techs or MLTs for that position. But for whatever reason, it seems like most infection control officers that I know of are RNs, okay? But they oversee the entire process, and you gotta check in with them. I'm sure there was somebody that was kind of overseeing.
It was the same way that did my TB skin test, but I can't remember.
Okay, let's look at number 4, personal protective equipment. Guys, I'm gonna go through that pretty quick because I feel confident you know what I'm talking about. But PPE stands for personal protective equipment. Just remember, gloves, lab coats, eyewear, safety-toed shoes, okay? That's about the 4 biggies on personal protective equipment. Hand hygiene, very important. If you were in the nursing program and in a lot of MLT programs, one of the first practicals that they make their students do is they actually observe you washing your hands, and they want to see that you're doing it step by step in the perfect scenario, okay? So they got good pictures that you can look at. So if you will, and this is the answer to one of your objectives, this is objective 5, that deals with the proper way to wash your hands. So it's short, so we're gonna go over it real quick. Procedure, the first thing you do is it says you wet your hands with warm water. You do not allow parts of the body to touch the sink. Number 2, you apply soap, preferably antimicrobial. Number 3, rub to form a lather, create friction and loosen the debris. Thoroughly clean between the fingers and under the fingernails for at least 20 seconds. Include the thumb and the clean. Number 4, rinse your hands in a downward motion to prevent recontamination of hands and wrists. Number 5, obtain a paper towel from the dispenser. Number 6, dry hands with a paper towel. And number 7, turn off faucets with a clean paper towel to prevent contamination. So, after just read that, what do you think, out of those instructions, which one do you think is probably the most missed that people do not do?
It's always the one turning off, because people will reach up and just turn it off with their hand.
They don't use a paper towel to turn it off. I've done that. I mean, I'll tell you right now, but when I'm actually thinking about it, I will use a paper towel. And I would recommend using a paper towel to go out the door when you leave.
Oh, yeah.
You know, it's really nice, sinks that you walk up to that have a foot pedal. Because, like, at Walmart, that's what they have at Walmart. You walk up, put your foot on it, water comes on, wash your hands, take your foot off, it turns off. There's none of that. They eliminated it. They
So
need
if you
that
see
in
questions
hospitals.
about that, I'm not gonna make you guys do a practical and proper hand washing, but there are a lot of programs that do. It's just very important you wash your hands. I know you guys have seen people wash their hands. They probably don't do it for a minimum of 20 seconds and stuff like that, but you're supposed to. Okay, people do take shortcuts. Just remember, in the lab, it's gonna be a little bit different, because I was thinking about this last night when I was reading some of this stuff, and I thought, I was thinking back when I worked at a lab, I would put on a pair of gloves in the morning when I started. And we're gonna talk about the first thing I do is start doing my quality control and urinalysis, doing everything. But sometimes I would have those gloves on for an hour and a half before I took them off. Because, obviously you cannot change gloves between every single specimen you touch. You would go through 20 boxes of gloves a day, all right? So just remember, you do need to change them periodically. And, my rule was, and I didn't necessarily read it in a book, but if I felt like I got any type of serum or plasma on my gloves at all, I would change gloves. But you're gonna see real quick, the more you work in a lab, you're gonna get real good at it. And you're gonna know, like, if you see a tube that's got a little bit of plasma sticking on it or something, you just get where you're real clean about it. You're gonna be surprised. Your gloves will look brand new even after you've been working on them. But you do need to change them periodically. Don't just leave the same pair of gloves on all day, okay? Another thing that I'd like to have a little bit of a discussion with you about that's not necessarily in your reading, be careful about keyboards that you're touching when you're working in the laboratory. I know a lot of labs, they have what's called clean computers and dirty computers. But realize how many people have been typing on that keyboard. Labs go for 24 hours a day, all right? And, you can pretend that everybody is as self-conscious as you are about wearing gloves and things like that. But just saying, be real careful. I'll give you a perfect scenario that I know I've probably broken this rule. Let's say you're fixing to go to break and you just, just taken off your gloves and you washed your hands, and for whatever reason, you hear the phone ringing in your department, and they say, hey, I need the results looked up on John Doe for a urinalysis. So you go over there and you start going under the computer to look up to see if that's resulted. Think about what you just did, okay? You just started typing on a keyboard that everybody has been, even if they got on gloves, what's on the ends of their gloves, right? And so just be self-conscious of that, okay? Think about how dirty those keyboards are. Okay, moving on to number 9, there's a real important section on number 9, it is biological waste disposal. A lot of people, they don't know this, so this is kind of important. It says all biological waste, I'm on the very first sentence on page 9, all biological waste except urine must be placed in appropriate containers labeled with the biohazard symbol. Going down to the next paragraph, it says urine may be discarded by pouring it into a laboratory sink. It says under a plexiglass countertop shield, that probably won't happen. You'll probably just pour it down the sink. It does say care must be taken to avoid splashing, and the sink should be flushed with water after specimens are discarded. Disinfection of the sink using a 1 to 5 or a 1 to 10 bleach solution should be performed daily. So you will see text pouring urine containers down the sink, and I mean pouring not just cups of urine containers.
About 24 hours, that is what.
Yes. Jugs. I'm getting old. Hurt. All right. This is a 24-hour urine container. All right. You're not going to be tested over this, but I just want to prove my point. There are certain tests that we have to do in the laboratory where we have to quantitate how much urine they voided in a 24-hour period. You don't want these sitting out at room temperature, okay? Because it doesn't take long, I don't care if they got a lid on them or not, you'll start smelling that, right? So, what a lot of times people will do is you pick up this, of course you'll have on gloves, and they've got a grid over here for what the volume is, record the volume, and then you're gonna take an aliquot of urine out of here, in other words, a sample. You don't need this much urine to do the test. The only reason, Bianca, you mind shutting that door? The only reason that there's even this much urine is it's vital that you know how much urine they voided over a 24-hour period. You don't have to have this much urine to do the test, okay? So I know one of the rules at the lab I worked at is anytime you had a 24-hour urine is you've got to record the volume. As long as you do that, you can maybe pour off a cup and then get this stuff gone. Like go pour, and we pour it down a sink, and then we follow it with lots of water, okay? Now where you will run into trouble, and anybody that works in a lab will agree with this, is what happens is people pour it down the sink, and even if you follow it with water, after you do that so long, all of a sudden people in the lab are going, what's that smell? And it's the whole sink, okay? It's coming from the sink, and that's when you need to flood it with some bleach and stuff, and then it'll go away. I know everybody knows this, but you need to be able to, one of your objectives needs, in the front of this chapter says you need to identify the warning labels, okay? So here's your first one you need to be able to at least recognize is the biohazard symbol. Okay, let's talk about chemicals. I don't think that you're going to be dealing with many hazardous chemicals in the lab because of the safety protocol that they require. But there is a section that I want you to highlight in your book. And this also goes for chemistry. I don't remember if I told you this or not in chemistry lecture. I'm on page 10 in the right-hand column under chemical handling. Go down to like the 4th line under chemical handling, and it says acid should always be added to water to avoid the possibility of a sudden splash caused by the rapid generation of heat in some chemical reactions. That is not one of your objectives, but that is a very important point that I want you to remember, okay? There's a review question in the back of the chapter on this, and you very well could see that on your exam. Chemical hygiene plan, that just means all labs have to have a plan, basically a place in order dealing with chemicals. It can involve everything. I'm still in the right-hand column on page 10, appropriate work practices, standard operating procedures, the wearing of PPE, engineering controls, employee training requirements, and medical consultation guidelines. Chemical labeling. Remember in chemistry when I told you about the NFPA symbol, National Fire Protection Agency symbol? You guys remember this? Okay. There is a picture in your book. We'll come back to here, but if you'll turn to page 13, that picture on page 13 is this picture that I'm holding in my hand. Okay, remember I told you about the color codes? Be aware of the color codes. Don't memorize the whole thing, but you need to at least know the basics. Red has to do with flammability. Yellow has to do with the reactivity, and blue has to do with health hazards. You want a low number. They're rated from 0 to 4. You want low numbers for that. Safety data sheets. This book hasn't changed to the new word, but make sure that you read over material safety data sheets on page 10 going into 11. And this basically has to do with chemicals. It lets you know everything that you need to know about a chemical that's in your lab. If it can cause your skin to burn. A lot of times it'll give you a toll-free number you can call. First aid procedures. How to get it up if there's a spill, right? Called safety data sheets or MSDS sheets. page 11, radioactive hazards. There's only really 2 points I want you to know about radioactive hazards on page 11. I want you to be able to recognize that symbol on page 11 as a radioactive symbol. And who do you think our #1 patient of interest is to stay away from anything that could possibly be radioactive in a hospital?
Babies?
Pregnant women, or pregnant people, yes. All right. Pregnancy, you'll see signs that say things like, hey, I'm covering myself, I don't want nobody to see me, all right? Hey, I'm just telling you that, you know, again, this is something you shouldn't have to study, but if you've ever been to an ER or anything, they're always gonna tell you, are you, or is there any way you could possibly be pregnant?
Right.
I've already gave you guys the lecture about, you know, if you're a female, probably over the age of 12 or 13, you may be mad when you leave if you find out you got charged for a pregnancy test, but they're gonna do a pregnancy test on you if there's an x-ray involved. Because even if you tell them 100% no way you could possibly be pregnant, if they end up doing an x-ray on you and then it comes out to find out later that you were pregnant, there could be issues with that institution, okay? So a lot of times, you'll know because if you're working in the laboratory of a hospital, they do a lot of pregnancy tests and you'll be surprised how many negatives you get. I mean, I would say the ratio, when I used to work in the lab, all those pregnancy tests would come to ER, I would say I did 40 to every one that was actually positive.
Oh, wow.
Well, it's just, you know, they're doing it on everybody.
Just a check.
To make sure, because those people are on their way to having an x-ray.
Right.
The only thing I can tell you that in the lab is there used to be tests, and they don't do them very anymore. There used to be a test that used what's called a radioisotope, and those in a roundabout way have to do with radioactivity. This is gonna mainly be done with people that are doing x-rays, okay? Electrical hazards, you need to know that symbol on page 11, bottom section on page 11. It does say this does fall under one of your objectives, but note the symbol for electric hazards. Just understand, if you're working in a lab, you're probably gonna be around all sorts of electrical equipment. That's one reason they don't want you having water out in the laboratory. You don't need to be drinking a water bottle. You'll probably see it at clinicals. Somebody will be drinking coffee or they got a Mountain Dew or something right by the machine, but they're not supposed to, okay? They won't mean it, but if they ever spill that into that machine by any way, that can cause some major issues. All right, we've still got objectives dealing with operation of fire extinguishers and the acronyms for what you do in case of a fire. So you need to be very familiar with pages 12 and 13. Again, remember the acronym for what you do in case of a fire is RACE. And the acronym for how you operate a fire extinguisher is PASS. And you need to know what each one of those letters stand for. They talk on page 13 about the different classes of fires. I just noticed that table at the bottom of page 13, they've got a class K. That third class K, that will not be on your test. It says grease, oils, and fats, and that used to fall under class K.
That's usually what they have in the dietary things.
Okay. All right. Anyway, kind of go by what I've told you in lecture. Class A is just your regular stuff on fire, wood, paper. I want you to think the class B fires is liquid fires, things like gas. Unfortunately, I would have said grease, of those things, and then class C is going to be your electrical fires. Remember, most fire extinguishers are going to utilize a ABC type fire extinguisher that uses what's called dry chemical, to where you can utilize that on any type of fire that you were to see. Okay, everybody good so far?
Yes, sir.
Before we move on, that should take care of the safety issues. We'll be moving into quality assessment. So this is a good spot to take a break. So how about we meet back in here at about